Okay, we're going to be rotating by coordinates again, but this time we're going to specifically focus on rotations of 90 degrees counterclockwise. Okay, now a rotation of 90 degrees counterclockwise, and we spoke about our quadrants as being quadrant 1, 2, 3, 4. That's starting here and turning it back the other way. Now, the reason we're doing that is because that is also known as, if we come all the way around here, it's also a clockwise rotation of what?
270.
Of 270, right. So that's the same thing. So if they give you something that's 270, just recognize that, well, 270 clockwise is the same as 90 counterclockwise. And vice versa. If they tell you 270 counterclockwise, it's the same as 90 degrees clockwise. So we've already done 90 degrees clockwise. Let's try 90 degrees counterclockwise. Well, our rule here states that we take the coordinates and we invert them. But instead of making the x the opposite, we make the y the opposite, right? And we're always rotating around the origin. It's not on any specific point here. So let's extend this page a little and write down our coordinates and plot it. So our coordinates were 6 and 8, 7, 3, 2, 1, and 3, 4, right? Well, a 90 degrees counterclockwise rotation will invert our points, so we have 8 and 6, but what's going to happen?
The y becomes negative, so
8 becomes the opposite, right? Here we're going to get 3 and 7.
But the 3 becomes negative.
Great.
And the negative 1, 2.
Great.
Negative 4, 3.
Good. So you understand that idea. So we'll plot this quickly, and then we'll go to a harder question. So first one is negative 8 and 6. Negative 3 and 7. Negative 1 and 2. And negative 4 and 3, right? We'll draw our lines to this guy. And it looks like we got, yeah, we got that same shape. And around the origin, what's happened has been shifted back 90 degrees that way, right? And if I actually group this, I'll quickly do that. Group it. You'll get the idea that when I turn it 90 degrees, he's the same shape he was before, yeah, right? So there's a 90 degree counterclockwise around the origin. So let's do a little more difficult of a question. We have this guy here. Okay, this guy's involved in all coordinates. So again, we're going to write, or sorry, all quadrants. We're going to write all the coordinates out. We have 2, 4. We have 3, negative 6. We have a negative 6, negative 4. And what's the last one?
Negative 4, 1.
Great. Now, following this rule, we invert them, so what will we get?
We'll get 4, 2.
Yeah, but?
The 4 becomes negative.
Great. The 4 becomes opposite. Okay. How about in this one? We're going to get?
You're going to get negative 6, 3.
Yeah.
But the negative 6 becomes positive.
That's right. We flip that sign. Good. We're going to get?
You'll get negative 4, 6, but the 4 becomes positive.
Okay. And it's not just 6. It's negative 6. Because it's a negative, it still stays a negative. It stays the same coordinate as before. And in this one, we're going to get?
1, negative 4, but the 1 becomes negative.
But the 1 becomes negative. Good. So now we plot these coordinates. We get negative 4, 2 as one coordinate. 6 and 3 as 1. Negative 1, negative 4. And 4, negative 6. I kind of did those out of order, but that's fine. Good. Still blue. So we connect them all. And what we're going to notice, again, I'm going to take the original guy and just rotate him. If I rotate the other guy, we notice we're getting that same shape. It's the same shape, except they got rotated around the origin, where I just kind of just rotated that one from the middle. Okay? So there we go. We've gotten the exact same shape with a 90 degree counterclockwise rotation, just by knowing what coordinates to use. Okay? So that's what we would do for both of those. All of those get moved, and all of those get moved.